On a sunny summer day, we usually carry an umbrella or use a sunscreen. Do you know why? It's because, to an extent, we all can see the harmful effects of the sun's rays. The tanning and burning of the skin are the effects observed normally. However, these are the least harmful, because sun rays can also cause skin cancer and cataract. With the increasing atmospheric pollution, we are being exposed to more and more such risks. Let's understand how. Sun rays contain ultraviolet or UV radiations. The second layer of atmosphere, or the next layer of troposphere, is called the stratosphere. In the upper zone of stratosphere, the protective layer of atmosphere called ozone layer is present. Ozone is produced when the ultraviolet radiations collide with the dioxygen molecules present in this layer. First, the UV rays dissociate a dioxygen molecule into its respective oxygen atoms. This oxygen atom, called nascent oxygen, then combines with another oxygen molecule to form an ozone molecule. As an ozone molecule is thermodynamically less stable, it undergoes dissociation to produce oxygen molecule and oxygen atom respectively. Hence, the above reaction results in dynamic equilibrium between ozone and its corresponding oxygen molecule and nascent oxygen. The ozone forms a thin layer surrounding the Earth's planet. It protects animals and plants from the harmful UV radiations by acting as an umbrella that absorbs most of the UV rays. Although the formation and dissociation of ozone is a continuous process, it has been observed that the ozone layer is depleting rapidly due to the increasing pollutants like chlorofluorocarbons or freons in the stratosphere. These compounds are non-reactive, non-inflammable and non-toxic organic compounds that are constantly being generated from refrigerators, air conditioners and electronic industries, to name a few. When these compounds reach the stratosphere, they are hit by the UV radiations and dissociate into corresponding fragments, releasing free chlorine radicals. These free chlorine radicals react with the ozone and form chlorine monoxide radicals and oxygen molecules. The chlorine monoxide radicals form even more chlorine radicals by reacting with nascent oxygen. Thus, the chlorine radicals are constantly regenerated and they keep reacting with the ozone to form chlorine monoxide. Thus, ozone gets depleted in the stratosphere. In Antarctica, ozone depletion reactions occurs in spring as it requires the presence of sunlight. During the dark days of the winter, the region gets covered with polar stratospheric clouds. During summer, nitrogen dioxide and methane react with chlorine monoxide and chlorine free radicals and form stable reservoir compounds like chlorine nitrate, ClONO2, and hydrogen chloride, HCl, respectively. In winter, the polar stratospheric clouds provide a surface by which chlorine nitrate hydrolyzes to hypochlorous acid and nitric acid. Also, chlorine nitrate reacts with hydrogen chloride to form chlorine molecules. And the chlorine-containing gases, along with nitric acid, form cloud particulates. Due to the lack of sunlight, these clouds remain chemically stable for almost 3 months without causing any harm to the ozone layer. However, during spring, in the presence of sunlight, the hypochlorous acid as well as chlorine molecules undergo further photolysis to form chlorine-free radicals. Thus, in spring, chlorine radicals which are constantly added initiate the chain reaction. This free chlorine radical is initially removed by reaction with ozone to form chlorine monoxide. However, it reacts with another oxygen atom, regenerating the free chlorine radical. As the rate of the chain reaction taking place is very high, ozone has depleted completely from a large area over the southern hemisphere, forming a hole in the ozone layer. This is called the ozone hole. The increasing use of fossil fuels and electronic goods has led to increasing pollution. This has thinned down the ozone layer over many places at an alarming rate. As a result, more UV radiations are entering the troposphere, causing aging, sunburn, skin cancer, and cataract, besides damage to reproductive functions in some fish. In plants, UV radiations cause mutation of cells by affecting plant proteins, increase the evaporation of surface water through the stomata of the leaves, and kill phytoplanktons. UV radiation also decreases the moisture content of soil and fades paints and fiber, causing huge economic losses. Therefore, we all need to ensure a reduction in stratosphere pollution by reducing the use of chlorofluorocarbons, nitrogen dioxides, and methane-releasing compounds.